Hello everyone, welcome to my experiments on exploring the refractive index of different liquids. In this video, we'll explore what refractive index is, explain its importance, and then run and analyze the experiment. Refraction is the phenomenon where light changes direction when it moves from one medium to another. This occurs because the speed of light decreases. To quantify this, we use what is called the index of refraction, symbolized as n. It is defined as a ratio of the speed of light in a vacuum to the speed of light in the material. So the greater the reduction in the speed of light, the higher the index of refraction. Now, what controls the speed of light in a material? It is determined by two properties, the material's electric permittivity and magnetic permeability. In most materials, however, the magnetic effect is minimal. That simplifies our equation to the index of refraction is approximately equal to the square root of the relative electric permittivity. This shows that the index of refraction is directly linked to the dielectric constant, which reflects how easy it is for material to become polarized by an electric field. Now, what influences this polarization? Mainly the size of atoms or ions in the material. Larger atoms or ions tend to have more electric polarization, which slows down light more and increases the index of refraction. Determining the refractive index of a material matters because it tells us how light behaves when it enters or passes through that material. This has plenty important applications across science, engineering, and everyday life. For example, we can use refractive index to identify materials. Different substances have unique refractive indices, so measuring it can help us figure out what that material is or if it's pure or contaminated. This experiment will be exploiting two key concepts, total internal reflection and critical angle. Total internal reflection is when light traveling from a denser to a less dense medium reflects entirely back into the denser medium. And critical angle is the minimum angle of incidence at which total internal reflection occurs. When shining a laser in a liquid of known depth, we can measure the diameter of the circle the light makes. Using the following formulas, we can then relate these values to calculate critical angle and then refractive index.